Hello, yeah, this seems pre-recording. Welcome to my tutorial. Today I'm going to be doing, going over recursion, and I will do some dynamic programming. So I've done some setup here, ignore this. The main thing is recursion. So class Fibonacci, we're going to make a new thing. So what is recursion? It's when a function calls itself. So let's say public int get Fibonacci number int x. Return 0. Ooh, that should be an I. So, like I said, recursion is when a function calls itself. So, there's two things to make it work. It needs to call. You need a base case, obviously. So, let's do something simple like a Fibonacci number. The definition of Fibonacci is, so if the fifth Fibonacci number, it's equal to the fourth plus the third. So, this case, we will do what would the base case be here? It would, so if x equals 0, or, x equals 1, return 1. Because Fibonacci is defined as the... Okay, I think that's first and second. Yeah. So... Yeah, Fibonacci of 0 is 1. Fibonacci of 1 is 1. So, our base case is this. Otherwise, what do? We will return get Fibonacci of x minus 1 plus x minus 2. So, if we do Fibonacci of 2, it will be return Fibonacci of 1 plus Fibonacci of 0, which will be 1 plus 1 is 2. And, so let's try that out now. I'm just going to comment this preparation I did out. So, Fibonacci, fib equals new Fibonacci. That's just a class, so console.writeLine fib dot get Fibonacci number of, let's say, 0. And this will be 1 and 2. We're going to control F5. Let's see a terminal capture screen. There, you can see... Oh, I guess that doesn't move around. Yeah, whatever. You could see it's... Oh, something's not right. Something does not seem right there. Let's turn that off. Well, that's interesting. It's cut off a bit, so... Why is that? Yeah, why does that happen when I try to... Whatever. No, that's fine, that's fine. Yeah, that's... So instead, we're going to do... let's just do plus... There, okay, so you can see it's 1, 1, 2. So Fibonacci. So what if we instead did Fibonacci of 8? It's 34, and let me just Fibonacci 8. What did I say it was? 34? Yeah, that is 34. I might be off by 1 in I might be off by 1, and this should be a 1, and this should be a 2, but that's not really important right now. The point is to show recursion. So what's that do? It calls Fibonacci of 8 will go into here. It will go 7 and 6. This will go 6 and 5, and then this continues. Now, this isn't always the most efficient way to do this, because let's say we did something like 100. It will take a bit. Yeah, this should take a bit because recursion going from 100, 99, 98, blah, 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 blah. Point is, you can see, this does take much longer to do, so let's do more 50. That should speed things up. Yeah, it's just taking forever because the recursion will go all the way down to 0 and then 1, and yeah. So, how can we improve this? That's where this code I did comes in. And that's dynamic programming, so let's place this here. So we're going to do, this will be dictionary int dict equals new dictionary. We'll probably have to import that. Never mind, we won't. So give me 1 second. So this is we're going to use a dictionary for dynamic programming. Dynamic programming is essentially you have a list and you save values and you can refer back to them later if required. So in this case, we will get Fibonacci number. What will we do? We'll go to var temp equals dict dot try get default value, and that's going to be x or out default. Let's just say out val. Oops. That should be like that, and this should be int val. Actually, that should be bool. Let's just say booly contains. So what's this do? This will give us true or false whether it contains the value or not. And if it does, it will give us, so if contains equals false, at this point, we will return this. Sorry. This goes to the really beginning. Then this return will go here. Else, return val. Actually, we don't even need the else. We can just return val. So what's this do? Actually, let me make a constructor. Public Fibonacci. Let's just do that. Dict equals, oops. This is class-based stuff. Don't worry about it right now. That's not the focus. So now, how's this work? We have a dictionary, which is, if I pass it, let's say 1 as the key, it will return whatever the value I set was. So I'm going to need to do a bit more. So let's say if it's false, int fib1 equals that, and int fib2 equals that. Then we'll return fib1 plus fib2. Why am I doing this? Because, yeah. So what we're going to do is dict.add. I'm a dad or default. Oh, that's fine. And this will be x minus 1 fib1. Dict.add x minus 2. Sorry, that should be minus 1. And fib2. Oops. So what this is doing is we get the x minus 1 value and store it in fib1. Then we want to store it in our dictionary so that we can easily reference it later. So in this case, well, what will happen is we'll obviously get x minus 2 when we call this. And this will go down, try and get default value, and yeah. So let's try tutorials. Let's instead do of 20. No, let's say 5, 6, and 20. Oopsie. We're just going. Item with the same key has already been added. Okay. Oh, actually, we shouldn't need that. Item with the same key has been added, huh? Yeah, I knew as soon as I started recording something was going to come out. So let's remove this and dict.add x and fib1 plus fib2. That should solve. Yeah, that fixed it. Okay. So just ignore this. That's not required. So 2, 3, 211. Yeah, that seems right. Now why did this happen? So can we time it? Yeah, so this is where I'm going to do some timing. Or never mind. So 6, it will go, okay, I need to get Fibonacci of 5 and 4. So it will go, does it have 6? No. Then it will get Fibonacci of 5 and 4, which will come down here. It will go, oh, I have, no, this will be true because the dictionary contains that value. It will store this value in here. Then we just return Fibonacci of 5, and there's no additional recursion calls, which makes it quicker. So if I were to, let's see, I did that. That's really fast then. If instead I did 21, once again, quite fast, because it's just grabbing 20 and 19. What if I did 30? It should be a tad faster. Yeah, because we have less calls. Because we're no longer going all the way down here. This will give us the dictionary value of all the previous ones, and then this is really quick. So we could even go all the way down to 50. Yep, so let's delete that. See, as you saw without the dictionary, that was quite slow. So let's do 100, which we know was really slow. And oh, okay. I know what's going on there. Yeah, let's try unsigned uint, maybe? So let's say index. No, that should be int. Then uint. Okay, so what is happening here is actually easy to explain. We're getting integer overflow. So, gosh, I didn't want to talk about that. Integer overflow. So let's just get rid of that. Console.writeLine integer? No. Int dot. Let me go Google. Okay, so what's the max int? It's something like that. So if I were to let's go up 60. Yeah, that makes sense. Then 70. Let's see where we get our overflow. Overflow, yeah, but 1, 2, 3, 4, 5, 6, 7, 8, 9. What is 1, 2? So I suspect we're getting our overflow here. Yeah, just a couple more should do it. So 190 maybe? $95. Let's remove that for now. Oh, okay. Let's go back to 80. Yep. I guess something just messed up. So let's try 75. Well, you can see what's going on there. 79. Yeah, see, we go to a negative number. So 78, there's going to be a certain point. Yeah, so why does that happen is, oh gosh, I didn't want to talk about it. Whatever, we're going to talk about that. So ints can go between negative, I think it's 8 to this. Why is that? Because that's just integer looks like, so let's give random integer 0, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and do. That's an integer. It should be 4 bytes. This is 1 byte, 1 byte, 1 byte, 1 byte. And each one gets increased. So this will be 1, 2, 4, 8, 16, 32, 64, 128, then 256, yeah. And this 0 should represent whether it's a positive number or a negative number, and that has to do with 2's complements. I'm not going to talk about that. So this is the max int. If this is a 1, that's the lowest int. That's just how it is. So what's going on is when we go too high and it does addition, this will flip over to a 1 because of overflow, and that makes the number negative, and it's just, we're going above the max int, so it traps all the way down to the beginning and starts going up. So yeah, not much I can do about that except to use a different type, but that's just because, yeah. So point is, I've now showed off recursion, and I've showed off dynamic programming. So to review, recursion is you calling a function, one function calling itself. In this case, that's this. Fibonacci number of x calls Fibonacci number of x minus 1 and x minus 2. And the dynamic programming portion is storing the values to make future calls much, much faster. So yeah, that's it for this tutorial. Thank you for watching, and have a good day. How do I stop?